Welcome to Gnana Deeksha Concept-Based Digital Learning. I am Roja, postgraduate teacher in math, working at TSWRS Gajwel, Siddipet District, Medak East. Children, everything we see in the world around us has a shape. What is a shape? A shape can be defined as the form of an object or its outer surface. We can find different two-dimensional shapes such as squares, rectangles, circles, three-dimensional prism, cylinder, sphere in the objects we see around us. Children, here are some objects of different shapes which we use in our daily life. Bangles, rings, coins are in circular shape. Hangers are in triangular shape. Paper sheet is in rectangular shape. Jewelry box, matchbox are in cuboidal shape. Egg is in oval shape. Ice cube is in cuboidal shape. Biscuit packet, powder tin are in cylindrical shapes. Everywhere we go, we see lots of different shapes. Isn't it, children? Bunty and Bubbly are playing with toys. They are enjoying with friends and toys. They are dancing and singing. It's in the shape of a pyramid, ice cream cone and a sandwich, a pizza slice and a lemon pie. It's the shape we very much like. It's in the shape of a birthday hat, coat hangers and my doormats, my house rooftop and a fair tree, striped anglefish in the deep blue sea. Hope you enjoyed the song. Any guesses which shape it is? Exactly, triangles. Triangles, we love triangles. We love triangles. Children, today we will learn about triangles. Learning outcomes. At the end of this class, you will be able to identify and classify the types of triangles, to understand and define Pythagoras Theorem and its applications in real-life scenarios, to apply the knowledge of Pythagoras Theorem to solve the problems. The main branches of pure mathematics are algebra, geometry, trigonometry, calculus, statistics, and probability. Geometry is the branch of mathematics concerned with the size, shapes, positions, and dimensions of things. A triangle is the basic and important shape in the world of geometry. Dear children, we see many structures made of triangles. The shape of the pyramid is a triangle. Pyramids are located in Egypt. The pyramid of Khufu at Giza is the largest Egyptian pyramid. It is the only one of the 7 wonders of the ancient world still in existence. The truss bridges have supporting structure constructed in triangular shapes. The triangle is the common in all sorts of building supports and trusses. The overall shape of many bridges is in the shape of a catenary curve. Why do you suppose triangles were used instead of another shapes? What if the structure is in circular shape? The circle cannot hold the weight or force that is put on it. As it does not have any support, it can easily roll when the weight is added on top of it. So, it collapses. Even a square collapses. When force is added on it, it would flatten out. But when triangles are added to these shapes, the base gets support. The triangle gives strength to the structure and forms a strong base. Triangles, when combined with other identical units, provide support, solidity, and distribute the weight evenly. Triangles are the strongest shapes when it comes to building structures. There are nearly 186 triangles in the Eiffel Tower. These triangles give this massive structure great strength. The Eiffel Tower is an amazing example of upright equilateral triangle. In the next picture, we see a boat sail. Almost every boat has a triangular sail for the purpose of navigation out to sea to catch the favorable trade winds for the square sails to utilize. By using a triangular sail design and centerboard, it was possible to travel against the wind using the technique known as tacking. The roof of the houses are made in triangular shape. The roof truss is an obtuse angle triangle. This type of roof is constructed because it does not let water or snow to stand on the roof for a longer time. So, we conclude that the triangle is the strongest shape as it holds its shape and has a base which is very strong and also a strong support. Now, let's learn the definition of triangle. A triangle is a polygon with 3 sides, 3 angles and 3 vertices. The 3 sides and 3 angles are called 6 elements of the triangle. The 3 sides of a triangle are straight lines. Here, AB, BC and CA are the sides of the triangle ABC. The point of meeting of 2 rays is known as the vertex. Here, the corner points A, B, C are the vertices. In geometry, when 2 rays meet at a common point, they form an angle. Here, angle A, angle B and angle C are the 3 angles. Angles are measured in degrees. A triangle is denoted by the Greek letter delta. Let's learn the classification of triangles. Triangles are classified based on the sides and angles. Based on sides, the triangles are categorized as scalene triangle, isosceles triangle and equilateral triangle. In scalene triangle, any of the 2 sides are not equal. Here, all the 3 sides have different lengths. For example, a triangle with the sides of lengths 7 cm, 12 cm and 15 cm. Here, all the 3 sides have different measurements. In isosceles triangle, 2 of the 3 sides have equal length and the 3rd side has different length. For example, a triangle with sides say 6 cm, 6 cm and 8 cm. Here, 2 sides have equal length, isn't it? 6 cm and 6 cm. Next type is equilateral triangle. In equilateral triangle, all the 3 sides have equal length. For example, a triangle having the sides 3 cm, 3 cm and 3 cm. Here all the 3 sides of the triangle have equal length, isn't it? Children, we all know about 3 angles. What are they? They are acute angle, right angle and obtuse angle. What is an acute angle? An angle which lies between 0 and 90 degrees, above 0 and below 90 degrees, is called an acute angle. Next is a right angle which measures exactly 90 degrees. The third angle is obtuse angle, which lies between 90 degrees and 180 degrees. That means above 90 degrees and below 180 degrees. Now, just add one line to these three angles. We get three triangles. So, based on angles, the triangles are categorized as acute triangle, right triangle and obtuse triangle. An acute triangle is a triangle where all of the three angles are acute. They are less than 90 degrees. All the three angles are less than 90 degrees. A right angle triangle is a triangle in which one angle is right angle, that is 90 degrees. The other two angles are acute. An obtuse triangle is a triangle that has one angle larger than 90 degrees. The other two angles are acute. So, in all these three triangles, two angles are acute. So, based on sides, we have three types, and based on angles, we have three types. Right angles in our daily life. A vertical line and a horizontal line make most common right angles. However, diagonal lines intersecting each other also form right angles. Right angles are all around us. We can see right angles in the corners of a room, book, cube, door, table, windows, and at several other places. Children, we have already discussed what a right angle triangle is. Now, let's learn its definition and parts. A right angle triangle is a triangle in which one angle is a right angle. One angle measures 90 degrees. In a right angle, the side opposite to the right angle is called hypotenuse. Hypotenuse is the longest side in a right triangle. The adjacent sides to the right angle are called as base and opposite. Opposite is also called as perpendicular. These adjacent sides are perpendicular to each other. A right angle is represented by the symbol L. The relation between the sides and angles of a right triangle is the basis for trigonometry. What is trigonometry? Trigonometry is a branch of mathematics that studies the relationships between the sides and angles of a triangle. For instance, here is a cute little girl standing in front of a tree and looking at the delicious plum hanging from one of the branches of the tree, which is 13 feet high. She is standing 10 feet away from the tree and thinking, how can I reach that? If we draw the figure, we observe a right triangle in which two sides are given and the third side is not given. If we know the relationship between these three sides, we can find out the third side easily, isn't it? The relation between the sides of right triangle is described by Pythagoras Theorem. Now you may be wondering, what is a theorem and who is Pythagoras? A theorem is a statement that is proven to be true. A theorem is a statement that is proven to be true. Let's find out the origin of Pythagoras theorem and understand some facts. Pythagoras of Samos was an ancient Greek philosopher and founder of Pythagoreanism. He is often called the first pure mathematician. He is an extremely important figure in the development of mathematics. The Pythagorean theorem was one of the earliest theorems known to ancient civilizations. This famous theorem is named for the Greek mathematician and philosopher Pythagoras. Now, let us learn Pythagoras theorem. Pythagoras theorem states that for any right-angled triangle, the square of the length of the hypotenuse is equal to the sum of the square of other two sides. It states that for any right-angled triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the other two sides. That is, hypotenuse square is equal to perpendicular square plus base square. It can be written as an equation a square plus b square is equal to c square. Here, a is the length of the base, b is the length of the perpendicular and c is the length of the hypotenuse. Let us understand this theorem clearly by an activity. Are you ready? Let us consider the simple example of Pythagoras triangle, whose sides are 3 units, 4 units and 5 units. Here, units may be centimeters, meters, inches, etc. Here, 3 units is the length of the base. 4 units is the length of the perpendicular. And 5 units is the length of the hypotenuse. The relation a square plus b square is equal to c square tells us that a square is a into a, b square is b into b, and c square is c into c. Starting with the base, here the base is 3 units. 3 square means 3 times 3. 3 times 3 is 9 units. It is the arithmetic meaning. The geometrical equivalence of squaring 3 is 3 in each row. Here 3 rows. So in total 9 units. 3 square is equal to 3 into 3. Which means 9 units. This square represents a square area of 9 units. Next, look at the side which is 4 units. Here, 4 square means 4 times 4 equal to 16 units is the arithmetic meaning. The geometric equivalence of squaring 4 is 4 in each row. There are 4 rows. So total is 16 units. This square represents square area of 16 units. Finally, let's do with the hypotenuse, which is 5 units. Here, 5 square means 5 times 5. Equal to 25 units is the arithmetic meaning. The geometric equivalence of squaring 5 is 5 in each row. Number of rows are 5. So total is 25 units. This square represents the side whose area is 25 units. Now, we will substitute these values in the equation. A square plus B square is equal to C square. On substituting, we get 9 plus 16 is equal to 25 is the arithmetic solution. Here, LHS, left hand side, 9 plus 16 is 25, right hand side is 25. Are they equal? 9 plus 16 is 25. So, LHS equal to RHS. If we rearrange these unit squares, we observe that they are also equal. Isn't it interesting? Hence, we conclude that for any right angle triangle, hypotenuse square is equal to perpendicular square plus base square. Here, in this example, 3, 4, 5 is called Pythagorean triple or Pythagorean triplet. I am sure you must be thinking, why should I learn this? I will explain. Pythagoras theorem has a wide range of applications in many fields. Applications of the Pythagoras theorem in real life scenarios. The first one, navigation. In navigation, the Pythagorean theorem provides a ship's navigator with a way of calculating the distance from the ship to a point in the ocean. The same principle can also be used for air navigation. For instance, in this picture, a plane can use its height above the ground and its distance from the destination airport to find the correct place to begin a descent to that airport. Do you know, even NASA also uses triangulation to determine the position of spacecraft. Second application, architecture and construction. Pythagoras theorem is useful technique for architecture and construction. The most obvious application of this theorem is in the world of architecture and building construction. If an architect is building a square structure, he can split the square into triangles. Using Pythagoras theorem, he can easily determine the lengths of the sides. When laying a foundation, builders make sure that the angles of corners are right. Earthquake location. Geologists use the Pythagoras theorem when they track earthquake activity. If they triangulate the distance travelled by the faster waves by the slower ones, then they can determine the center of earthquake. It is a useful technique in many other fields. Management, farming, installation, production, etc. Now let's try to solve the problem of this painter who needs to determine how tall the ladder needs to be. The foot of the ladder is placed 6 feet from a wall. If the top of the ladder rests 8 feet upon the wall, how long is the ladder? In this question, a ladder is placed 6 feet from a wall. Let's figure this out. Here is the distance between the wall and the ladder. The distance is 6 feet, which is nothing but base. The length of the wall is 8 feet, which is perpendicular. Draw this figure. We observe that it is a right triangle. So, we can use Pythagorean theorem to find the length of the ladder. In this case, the ladder itself is a hypotenuse. We have base is equal to 6 feet. Opposite is 8 feet. So, using Pythagoras theorem, we know that hypotenuse square equal to base square plus opposite square. Let's substitute the values in this equation. Hypotenuse square is equal to 6 square plus 8 square, which gives 36 plus 64 adds up to 100. Taking square root on both sides, hypotenuse equal to square root of 100, which is equal to 10. So, hypotenuse equal to 10 feet. So, the length of the ladder is nothing but 10 feet. We can solve such problems easily using Pythagoras theorem. Now, let's recall what we have learned in today's class. Children, we have learned that a triangle is a polygon with 3 sides, 3 angles and 3 vertices. Triangles are classified based on their sides and angles. Pythagoras theorem states that in any right triangle, hypotenuse square equal to perpendicular square plus base square. Pythagoras theorem has wide range of applications in many fields. Now it's your turn. Children, it's your turn now. Why don't you try to solve a problem? Here is your assignment. Note down. A ladder leans against a window of a house. If the ladder is 25 meters long and the base of the ladder is 7 meters from the house, how high is the window? A ladder leans against a window of a house. If the ladder is 25 meters long and the base of the ladder is 7 meters from the house, how high is the window? Here, the length of the ladder is hypotenuse. The distance between the ladder and the house is base. So, what do you need to find here? Exactly. You need to find the height of the window. That is nothing but perpendicular side. So, use Pythagoras theorem and solve this problem. Everything around us is mathematics. It's about understanding. Thank you, class. I would like to thank our beloved Secretary Sir, our CEO Ma'am, Madhiti Kishore Sir, our Principal Sir for giving me this opportunity. Thank you.